We're looking at 2.5 implicit differentiation, but we're looking at select homework problems that involve finding vertical and horizontal tangent lines. So for 57, 58, we're finding points in which the graph of the equation has vertical or horizontal tangent line. And just to kind of help us remember how to find these, horizontal tangent lines can be found by setting the numerator of the derivative. So in this case, once we find dy dx, we set the numerator of dy dx equal to 0, and then we solve for x. To find vertical tangent line, this is where the slope is undefined, we identify the denominator of our dy dx, set that equal to 0, and solve for x. Okay, so 57 here, we're going to find dy dx first, find the derivative. Notice that we have x and y's that are mixed in with each other. It's not a nice clean function where y is isolated on one side of the equation and everything on the other side is in terms of x. We see y squared, we see y, we see x. So we have to go through implicit. So implicit means that we're going to find the derivative like we normally would for each of the term, but if we're involving y's derivative, we have to attach a dy dx. So 25x squared, we go through power rule, becomes 50x. 16y squared becomes 32y, but because we just involved y's derivative with respect to x, we attach a dy dx. 200x becomes 200. 160y becomes 160 times dy dx. Now, even though the y disappears, we are still involving y's derivative. So 160y becomes 160, but because we are applying the derivative for the y variable, we have to attach a dy dx. 400 is a constant, goes to 0. And then don't forget, if there's anything on the right side of the equation, if it's a constant, it also goes to 0. But it's already 0, so it's going to stay 0. From here, we just have to isolate and solve for dy dx. So I'm going to put the 32y dy and the 160 dy dx together on the left side, and everything else moves over to the right side of the equation. So 50x moves over, the 200 moves over, we change the sign. I'm going to factor out the dy dx and then divide everything over to the other side. So now dy dx is, the derivative is negative 50x minus 200 over 32y minus 160. Now if we want to find the horizontal tangent, we're going to identify the numerator, set that equal to 0, and solve for x. So here's the numerator of the derivative. We set that equal to 0. We solve for x. We get x equals negative 4. But we need to find the point, so we still need to find the y value where this particular horizontal tangent line is going to occur. So we're trying to figure out where that order pair is, where the slope is 0. So from here, we're going to plug in negative 4 in for x. And when we do that back into the original equation, and if we work that out numerically, it's going to give us 16y squared minus 160y. Factor those 16 out, we get 16y equals 0, y minus 10 equals 0, so 0 and 10. So there's two locations where the slope is 0, at negative 4, 0, and at negative 4, 10. Now moving on to vertical tangents, we're going to identify the denominator of our derivative and set that equal to 0. So whatever makes the denominator of the derivative 0 is where the slope is undefined, and that's what we're looking for. So we set the denominator of the derivative equal to 0. We solve for y, we get y equals 5. But we're looking for ordered pair, so we still need to find the x value. So we're going to take this 5, plug it back into the original equation, and solve for x. When we plug 5 in, we work our way down to clean everything up. And when we combine like terms, we're going to get all the way down to 25x squared plus 200x equals 0. Factor out the 25x. We get x plus 8 in parentheses. Set both equal to 0. So 25x equals 0. X plus 8 equals 0. So we get 0 and negative 8. So when y is 5, x can be 0 or a negative 8. So we have two separate order pairs where vertical tangents occur at 0, 5, and at negative 8, 5. Okay, 58, same idea, same steps. We start off finding the derivative. Notice again we have to go through implicit because we have x and y's mixed together. It's not going to be a nice clean function. So again, we find the derivative of each term. 4x squared becomes 8x, y squared becomes 2y, but we're involving y's derivative, so we attach a dy dx. 8x becomes 8, 4y becomes 4 dy dx, 4 becomes 0, 0 stays 0. Here we can begin to isolate dy dx, so leave the 2y and the 4 dy dx on the left side. Everything else moves over to the right side of the equation. We factor out the dy dx, divide the 2y plus 4 over, and then we have our dy dx. To find the horizontal asymptote, horizontal tangent line, we set the numerator of our dy dx equal to 0. 8 minus 8x equals 0, so x equals 1. So we still need to find the y value, so we're going to take the x equals 1, plug back into the original equation. We get 4 plus y squared minus 8 plus 4y plus 4 equals 0. Combine like terms, we get y squared plus 4y equals 0. Factor out the y, we get y equals y times y plus 4. We get y equals 0 and y plus 4 equals 0, so 0 and negative 4. So when x is 1, we have two separate y values. So we have two separate order pairs, 1, 0, and 1, negative 4. Vertical tangents occur where the denominator of our derivative is equal to 0. So we set 2y plus 4 equal to 0. Solve for y. So subtract 4 from both sides, divide both sides by 2. We get y equals negative 2. We still need to find the order pair, so we take negative 2, put it back into the original equation, and continue to simplify and solve for x. We get 4x squared minus 8x equals 0. Factor out the 4x, we get 4x times x minus 2. Set both parentheses equal to 0. 4x equals 0 and x minus 2 equals 0. So x equals 0 and 2. So when y is negative 2, x can be 0 or 2. So the order pair is 0, negative 2, and 2, negative 2. So we have two vertical tangents and two horizontal tangents.